We have a pretty stark choice in front of us. Who's going to build the rest of the nuclear reactors around the world? There are three options today for that. Russia, build your nuclear reactors around the world. You can have China build your nuclear reactors, or Valar Atomics.
Isaiah, great to see you again. The first nuclear reactors that were ever built were built in I think they were the Chicago Pile and X10 graphite.
That's right. Yeah. So we did the Chicago Pile 1, Chicago Pile 2, and then the X10 at Oak Ridge. Yeah.
Yeah. And basically those things were built in 9 months.
Yeah. The first one was built in 8 months. The second one was about 4 months. And then the X10 was another 9 months. So really, really rapid succession. Yes.
What do you think what has shifted in the past, 60 or 70 years that made it so it takes 15 years now, up from 9 months?
Yeah, we got worse at two things. Obviously, we got worse at licensing commercial nuclear reactors. That's pretty obvious, right? From 1979 to today, the NRC has granted 4 licenses for new reactors, right? So there's this clear stop in commercial nuclear reactors. But I think even more important is that we stopped innovating, right? We stopped turning on test reactors. There were, dozens of nuclear reactor experiments at Oak Ridge and Idaho and in a bunch of different places within the AEC. And we split the AEC out into 2 different agencies, so sort of a nuclear test agency, that was the DOE, and then the NRC for commercial. And unfortunately, neither of them have been able to do their job. So we're kind of standing here at hopefully a new moment, right? Some executive orders came out recently, and hopefully we're about to see that change. But you really have to have innovation. Innovation is the lifeblood of any industry. If you're not testing new things, you're not building new things, that industry is going to die over time, and your competitors will outpace you.
Yeah. Do you want to talk about a little bit what just happened as far as the Trump, stamp?
It's wildly exciting. I think that we're looking at a new era of nuclear energy, and specifically of American nuclear energy. This is all about dominance, right? I think we're shifting from a frame of trying to protect the U.S. monopoly to actually building again, right? These regulations and a lot of these rules came from a time when the United States had a perfect monopoly on nuclear. We were the only country in the world that knew how to do it. That was the case in 1946. The British knew it a little bit, but that was fine. And it was really just, how do we protect what the United States has? And unfortunately, we really slowed ourselves down more than we slowed anybody else down, right? We didn't stop all of our rivals from getting not only commercial nuclear, but even the nuclear bomb. And at the same time, we eroded our ability to innovate and to build. So this is a reset. It's about, we want American companies to be the best nuclear builders in the world. We have a pretty stark choice in front of us. We have 2 stark choices. Do we want to be a country that can build energy? Right? That's a choice, and that's an important choice, right, for a bunch of reasons, but artificial intelligence obviously accelerates the importance of that. The other is, who's going to build the rest of the nuclear reactors around the world? And I believe that there are 3 options today for that. You can have Russia build your nuclear reactors around the world. You can have China build your nuclear reactors, or Valar Atomics. And we're hoping that, after these executive orders, it makes it a lot easier for us to be that company.
Yeah. I was watching one of Jason Carmen's Frontier films, and
Yep.
I loved this line that you said, where you basically said one of our core values at Valar Atomics is to build nuclear reactors, you have to actually build nuclear reactors.
That's absolutely right.
Why
Yes.
is that, how did you come to that philosophy, and why is that so foreign?
Yeah, in order to build nuclear, you have to build nuclear. It actually is pretty simple. And every other industry seems to understand this, right? Or at least comes to learn this over time. So the space industry is a great example of this. In order to launch rockets, you have to launch rockets. SpaceX figured that out. They launched the Falcon 1. And people kind of laughed at them, right? It's like, what are these dudes doing in a garage building a rocket? But that quickly evolved, right? And it became the Falcon 9. And people took it a little more seriously, but, still, it's just kind of a smaller rocket. It's not as big as Space Launch System or anything that we're ideating in NASA at the time. And then it lands itself, right? Well, why did it land itself? Because they launched it enough that they could gather data and they could iterate, and now it lands itself. That's pretty serious. Now you get into Starship, and Starship is gonna break the price curve all over again. So you do what you do often, right? So when you're starting, you have to actually do the minimum possible thing as fast as you can, right? So that's our philosophy here. What's sitting behind me here, this is Ward 0. This is our first reactor prototype. This is called a non-nuclear reactor. So essentially, we built a nuclear reactor in 12 months, but we didn't put uranium in it, right? The paperwork to do, that we'd have to do in order to put uranium, this would take, 2 to 3 times longer than building it, right? So what you do is you build as much of it as you can. We got incredibly close here to a real nuclear reactor. If you put uranium in this thing, it would actually work. You could split atoms in this device standing behind me. Now, we don't put uranium in it, but we do as much as we can. So we put silicon carbide inside of there and we mimic a nuclear reaction, right? So we pull about 12 city blocks worth of power off the Los Angeles grid, run it through that core, and we can get actually above nuclear temperatures inside the core. So
Crazy.
This is
how hot is that?
So we can get the core temp momentarily as close to 2,000 degrees Celsius, right? So incredibly hot inside the core. We'll do high temperature operations, around 1,000, inch it up over time, right? The idea here is you want to envelope the system. You want to figure out how hot can you get this, what breaks first, what leaks first, how do your materials behave under different heat and pressure, and you really want to get to know the system. You want to know what breaks. So this is the only way to get experience in technology, right? So this, what I mean when I say, you have to build nuclear to build nuclear, is you don't learn that much on paper, right? You can spend years and years in analysis, years in planning, years in engineering, and you actually haven't gotten that much closer to the goal. Because when you actually go to build it, you'll figure out that bolt broke, right? This thing sheared, right? That seal leaks. This supplier actually can't supply the thing that they said they could, right? You have to go figure out all those problems in real time and real hardware. We've already learned so much in the last 3 months just building this thing and operating it. And, that information is ours now. Like we're fundamentally ahead because we decided to build quickly.
Yeah. So when I interviewed you last year, you were literally in Augustus's one room upstairs, and we just used part of his garage as the place. And there was a little logo behind you with made out of sheet metal. And today there's actually a thermal prototype.
Yes.
It's sitting behind you that you built on a seed round.
It's very exciting. Yes.
It's crazy. What's it been like for that transition from going from just sitting in a warehouse, not having some ideas on paper, to actually having it?
Yeah, I mean, it's been an insane year. I have never seen a team work as hard as this team has worked. I mean, genuinely, I have pictures of people sleeping on the floor, right out there on the floor. You might see in a couple of the rooms we have these sort of net chairs, beach chairs. And for about 3-week period of assembly, they were set up on the floor, and people would just fall asleep in front of the reactor and wake up a couple hours later and keep going. It takes unbelievable dedication. We've genuinely done something historic here. Building this in 1 year. We believe this is the most sophisticated thermal prototype ever developed, meaning as close as you can get to fission in a 1-to-1 scale as has ever been done before. And we did it in record time. So, we are hardcore dedicated to actually building the hardware, getting experience with it, determining the issues, fixing the issues, and moving on to the next model at a very rapid pace. And it is similar to the pace, that we were doing in the original days of nuclear, right? And I would argue that those first days of nuclear where we were building prototypes rapidly in a year or less was the only time that there was nuclear innovation, right? Since then, we haven't really been innovating on nuclear. We've been maybe maturing a plant design a little bit, changing things here and there. But all of the initial designs that we now have were piloted in a really short amount of time in the national labs, going very, very fast. So we're going back to go forward, going back in time to an older way of building, which is super fast, super iterative, and real hardware. We pay attention to the nuts and bolts, and we keep moving.
Yeah. How did you come to I think you basically created a relationship with the government of the Philippines.
That's right.
To figure out how to build a reactor faster.
That's right.
Right. How did that come together? Why'd you do it?
Yeah, we're super excited about this partnership that we have with the Philippines. We reviewed over 80 countries all over the world to figure out who has the best regulatory environment to move very quickly. Who really needs energy in the short term? Where can we solve a really big problem for somebody? And the Philippines has been an incredible partner. So yeah, we have a public-private partnership with them, and the flavor of that partnership is very collaborative, right? It's let's turn on a nuclear reactor together. Let's do it as fast as we can. They get experience, we get experience, and we're going to split atoms, in real life. It's going to be really exciting.
Yeah. So I know that you posted a while back on Twitter about basically this video of a few guys just dancing on a hill. And no one, everyone thinks that they're crazy. They all look crazy.
Yeah.
And then over time, basically a few more people join in and a few more people join in, and soon everyone's dancing.
Yes.
And you basically said, this is what the best early stage, founders look like.
Yes.
They just look like the crazy people at the beginning.
Yep.
What was that like for you, being that crazy person?
Look, I think I'm still that crazy person, right? I think where Valar is today is that, I've been dancing on the hill for a year, and I have those early people kind of around me now. So we've got in that video, you have the one guy and another guy joins in. That's Mark. And then we have a couple other guys and Kip and we have like maybe 5 people around. The team today is 35. It's fantastic, but proportionally, right, we're still a couple crazy people on the hill. And over the next couple of years, it's going to be very exciting. This is going to become a very, very large company that's going to power the world. And yeah, we're really excited about that.
Yeah. Have you like had any major, I don't know, personal changes since starting the company?
I think so. I mean, I hope so, right? Like, I hope that I'm getting better and better at this. But at the same time, I'm probably going to keep the chip on the shoulder that I have, for a long time, and that definitely propels me. So I think I've gotten hopefully a little bit better at communicating and inspiring and showing people that this company is going to be enormous, and that really is our ambition. We want to power the world. But I think we've stayed very, very true to the original principle, which is we want to split atoms in record time, and then we want to move on to the next model very quickly, and the next one, and that's going to lead to massive, massive scale. We want to make tens of thousands of nuclear reactors. I've had to learn a lot, of things very quickly, but I have the benefit of an incredible team around me with way more experience than I have, and that's how you move fast.
Yeah. Do you know why, or is there like a clear reason why there's like super valuable like startup companies that are like publicly traded that have never turned on a nuclear reactor in their entire existence, and they've existed for like 10 plus years?
Yeah, I think that there's a bit of a mistake going on in nuclear in general, which is it's a little bit of like software mindset. So let me contrast for you like how software companies work and how deep hard tech companies work, right? Generally, software companies, you're limited on your understanding of product market fit, right? You're really, really trying to understand what's the exact product that perfectly connects all of the customer's needs and then is scalable and replicable, to millions and millions of people all over the world. And so your early customer signals are incredibly valuable, right? MOUs with customers, revenue from customers, these early integrations with the customer are massive signal that you've got something, right? I think deep tech is a little bit different than this, right? So in deep tech, the customer actually maybe doesn't know what they want. And in fact, I'll go further. The customer definitely doesn't know what they want, right? So think about like SpaceX, right? If NASA was giving Elon feedback on the rocket that they wanted, right? So they want to get people to the International Space Station, right? And they want to be able to
telling him what to build,
right? And they want to put kilograms in orbit, these sorts of things. And Elon sort of like listened to NASA. We would not have the Falcon 9, right? The device that you build would look nothing like the Falcon 9. And it took Elon saying, like, I think NASA's wrong. Actually, this thing should launch. It should land itself, which was like laughed at, right? And so there's a certain extent in hard tech where you're on the edge of the future and you understand what the customer wants, but you're a layer removed from it. And I think that's intentional. So what does SpaceX do? They build these rockets, and they have a ton of conviction about how those rockets are shaped and how they're built. And then they separate that from the customer and they sell kilograms to orbit, right? And then they focus deeply on the cadence and on the operations and the supply chain and manufacturing, and like they make that rocket work perfectly. And then they just sell kilograms to orbit to the market. And I think that deep tech is shaped this way oftentimes, and we have the same conviction. So I think the mistake that people are making in the market is they go out and they form customer relationships, and they get utilities to say, yeah, we would take a couple nuclear reactors at that price point. And I look at that and I say, the demand is actually infinite, right? You can assume infinite demand on day zero. If you can build a nuclear reactor that is the right price and that is very safe and that has reasonable timelines attached to it, of course, you're going to be able to sell those, right? And so we focus all of our effort, all of our time on actually getting to that point. We want to get to the point where we are able to build, 100 nuclear reactors on a site, making gigawatts of power, as soon as possible. And the critical path through that is not, marketing, and it's not, customer relationships, and it's not, all of these different areas that people, like to focus on. It's actually technological competence, right? It's building, it's supply chain, it's manufacturing, it's data, it's testing, right? That is the critical path. That's what we focus all of our energy on. And unfortunately, I think the market doesn't quite understand that yet. Again, the market doesn't quite understand that like the problem, how is this market shaped? It's a capability constrained market, not a demand constrained market. There's not a problem market, there's not a product market fit problem here. If you can switch the polarity of an electric listen, like if you can switch the polarity of an electrical field, 60 times per second, and you can make 25 megawatts, and that device, is a low enough price point, like everyone wants to buy that machine, clearly. And so that's entirely what we focus on.
Yeah. So in that same vein, like, you want to build these like massive gigasites with hundreds of reactors on them, like in one place. And like America used to build or be behind like mega projects, and it feels like that's hugely fallen off recently. Like it's gotten to the point where, as recently as like a few years ago, SpaceX was getting fined for pouring potable drinking water on its, launch pads in the mission, in the pursuit of trying to get these, lowering the mass to orbit cost. How do you think we like change that?
So there's a couple of surface areas of contact here that we need to think about. On the mega projects themselves, I would say that Valar is much more focused on lots of manufacturing than on big construction, right? So a lot of these issues are eliminated by making the things smaller and making a lot of them. We're really bad at like large construction projects now, unfortunately. This is a labor cost problem. It's a labor tooling problem. It is an environmental problem as well. Construction just has a lot of, interface with regulation and with especially environmental regulation. So manufacturing more, constructing less helps you avoid a lot of these problems in tooling and labor and environmental. The other one is this class of environmental regulation called NEPA, right? So NEPA has traditionally been a huge headache for nuclear. Basically, every other industry has figured out a way to navigate through through NEPA and still be able to build things. Nuclear is just like this unfortunate area where we've decided that we need a full environmental impact statement before we do anything, right? And it's like, that's not what Congress intended at all. It's what's sort of grown up through the bureaucracy. So I think that, in the executive orders that came out recently, where the government is told to reconsider that constraint and see if we can make that a lot easier and a lot faster. So I'm bullish. I think that we will see a very different environment in the next couple of years. The other thing, though, is Valar is an international company. We build nuclear reactors all over the world. We want to build nuclear in all of the U.S., allied countries, and there are different jurisdictional constraints, all over the world. So we look for places, especially in the next couple of years, where it's very fast to build, very easy to build, and where we can solve, a huge problem very quickly. And then we work our way back to the United States as it becomes possible.
Yeah, so I know when like we talked initially, you didn't have like a concrete, we are going to build like a 1 gigawatt reactor, like a 5 or 10 or whatever. How did you like narrow down what the most logical path or logical thing to tackle would be?
Absolutely. So we started small, right? We said, let's be very cautious about predicting the future before we have experience in hardware, right? So, we hadn't built any hardware yet. So we said, let's not take a guess about what this commercial unit's going to look like yet. Let's instead build whatever we can, test it out, get to know the supply chains, get to know the metal, right? See what breaks, understand vendors, these sorts of things. And that has informed kind of our next step. So we do think we have a picture now of what that commercial unit looks like after having built this and tested it out. We think that's about a 25 megawatt electric unit. I think that's the right bite size. If you want a gigawatt, you build 40 of them, and that's great because it's really easy to stamp these out. Just make a lot of them, plug them in, you make a gigawatt. So we expect the commercial unit size to sort of think of this as like our Falcon 9, right? The Falcon 9 for us is Ward 3. It's a 25 megawatt electric reactor. It's visually, it's about 1.7 times larger than this. So imagine this 1.7 times scale up. That's a 25 megawatt unit. That's what we'll run with.
Yeah. What was the experience like? So you're initially at the Rainmaker place, and then suddenly you like move out of there and go into another location, only to realize like it's too small. You have to move again. What was that like?
Yeah. So we this is our third location. Technically, if you start with my office where I founded the company, this is our fourth location in about 14 months. All of this, like we do everything fast, right? We move quickly and we iterate and we adapt, right? So we hoped we were going to be able to build this reactor in our old location. Ceilings weren't tall enough, and we thought it's fine. We asked the landlord, can we poke a hole in the ceiling and we'll like build like a gantry around it, whatever.
What was that conversation like?
It was fine. Mark is an awesome guy. He's a really flexible dude. So, but we realized, we need to fit a crane up there and take the head off and all these things. But we just worked with what we could at a time. We couldn't, we're moving so fast. We couldn't even, we couldn't have signed a lease on this property, until we had gotten the seed round done. So you do what you can with the resources you can, and you always move fast. That's the biggest thing. When we finally decided on this location, this is just like who Valar is culturally. When we decided on this location, it was after 4 months of negotiation for another facility in El Segundo that again had the right parameters in terms of ceiling height, but the landlord just really could not get there on terms and like figuring out how to fix the it had a lot of work to do. So I just decided in an afternoon, like, all right, we got to be done with this. It's time to move. We got to go.
The goal is to build nuclear reactors.
We
not
have to build nuclear reactors.
Exactly.
The goal is built. Exactly. That's right. And so I called up the real estate agent on this place, and I said, I want to be in there in 3 weeks. We hadn't talked to anybody yet, but I knew that this property was there. I toured it while it was under construction. I said, that's the one. We're done. We're going. And so, I called him and I said, who's the fastest real estate lawyer that you know? I want a lease signed by Monday. And
was this like on a Friday or something?
This was on a Thursday. Yeah,
Thursday. So you had 3 days.
And so I called him, and he said, "Well, this guy's pretty fast." So I called that guy, and I was like, "Hey, what's the fastest that you can turn around a red line on a lease? It's a 30,000 square foot facility, pretty big facility." He said, "It's gonna take a day or two," and I hung up. And then I called the guy back, and I was like, "He wasn't fast enough. Give me somebody else." And so he gave me another guy, and I called him. I was like, "What's the fastest you can turn around a red line?" He's like, "I can get it to you tonight." I was like, "Sweet, you're hired." Okay. So we turned around the red line, handed it back, and in the meantime, my team had already been sort of prepped that look, this is an incredibly tight timeline. Like, we built this thing in 12 months. That is extraordinary in every frame, from design to engineering to GD&T to procurement to manufacturing to assembly to commissioning, right? That's an unbelievably short timeline. So we move fast in every single step. And part of that is I instinctively knew we're going to need a machine shop. Now, on paper, you don't need a machine shop, right? Because we've procured all these parts from vendors, and we're essentially just doing engineering, and we get the parts shipped here, we put them together, right? That's fine. Well, no, it's not fine, because vendors fall down, right? Vendors screw up, they miss timelines, they go slower. And so I told the team, look at the BOM, look at the bill of materials, and I want to be able to make 80% of this bill of materials in a shop that we own and we have commissioned and it's running. And I need that in 4 weeks, right? And David, my head of manufacturing here, was like, well, it normally takes about 3 months to set up a machine shop. And I'm like, yeah, no, but we're going to have it here.
We're going to get this done.
And he said, sir, yes, sir. And he did it. And he started that procurement process before we were even in this building. And we told him, yeah, ship to that location. We'll have access to it by the time the trucks get here. And we did it. It was sitting here running before Thanksgiving, which was extremely important because we were able to fix all the parts that came in that the suppliers got wrong, and other suppliers dropped the ball, and we had metal stock on hand, and we were able to hit the timeline that we intended to hit to the day, actually.
Insane.
But we would not have been able to do that without all of those pieces coming together. So look, we move fast, we move aggressively, we don't take no for an answer.
Yeah, that leads perfectly into the next thing, which is basically like, how the hell do you hire such like high agency cracked people that are just going to get shit done timelines that shouldn't be possible?
I can't leak too much alpha here. I would not leak too much alpha here, but I take hiring more seriously than anything else. Genuinely, like the people who are here are filtered through not just technical capability. That's ground stakes, right? You have to be technically capable, but you have to be driven. You have to be willing to put everything on the line. Everyone who joins here knows that this reactor may turn on in the Philippines, may turn on somewhere else, may turn on anywhere in the world, and we're going to go wherever in the world it's possible to turn on a nuclear reactor in record time. They're excited for that mission. Everybody's who's here is ready for this company to make the world's energy. I will say the one bit of alpha I'll put out there is like we index on anger. We like to find angry people.
You like to find why angry?
We like to find angry people because nuclear is this really incredible technology that's been sitting on the shelf for 40 years, right? And if you are in that industry, gaining experience, gaining wisdom, getting your head into it, and you're not angry that nothing's happening,
like what's possible, but
it's possible, and no one's doing it, and nothing's happening, and nothing's getting built, and no atoms are being split. If that doesn't make you angry, then you've sort of figured out a way to just coexist with that status quo. And we want people who
don't have fire in you.
Exactly. We want people who have not figured out how to exist in that status quo. And sometimes that means we find people who started there, got fed up, went into other industries, built a ton of cool shit, and then came back, right? Or they've been in nuclear, but they've just been angry the whole time. And like they get here and they're like, it's time to actually build. Like, we're going to do this.
They need to like do some hallucinogens or something.
No. They need to work on this. Yes, exactly.
Yeah. So when you were first starting out, you basically went through like 80 plus rejections, I believe. And, the whole like come back to me when you have a lead is a rejection. It's a no, right? They're not giving you a check. It's a no.
It's a no.
And you basically pushed through that. And eventually you got like one venture fund, Riot, who just like put in the entire thing. And then everyone's all like mad that you didn't come back to them when you had a lead.
Yes.
I think the like environment has changed quite a bit, and you've basically like built momentum,
Yes.
Right. You built
Absolutely.
momentum and traction, even though there's not like technically revenue or whatever.
Yep.
There's other proof points.
Yep.
Right. Like building this in, 12
Yep.
months. How do you think through like going from everyone's rejecting you based on some plan that you have
Yeah.
to you're going to go actually build a reactor because people gave you lots of money to do that?
Yeah. How did we build momentum?
Yeah.
So I've learned a lot about venture, and especially I think that pre-seed is this really funny category that people like misunderstand. I don't think that like this is probably super controversial, and maybe my investors will disagree with me about this, but I don't think that pre-seed should be treated like other venture rounds. When a kid sits down in front of you with no experience in venture, like if you're raising a pre-seed, it's generally because you're like from nowhere, right? Like you don't have the multi entrepreneur background, like deep network. If you did, you would just like raise a seed, right? So pre-seed is sort of like the kid just like got an idea and he's like, I can do this thing, right? And so like a round doesn't really make sense in that context. You like if you're a pre-seed investor and this kid's in front of you saying like, I'm going to build a nuclear reactor in record time, and then we're going to build 1,000 of them, and we're going to make the world's energy. You have to decide for yourself in that moment, is that person a killer who's going to get it done come hell or high water, and he will not stop until it's accomplished? And are his ideas right, and is he thinking about the problem correctly? Right, that's important too. But you have to decide for yourself in that meeting, and then you either write a check or you don't. Right? Because if he's right, like if he is that guy, he's going to find his way to the money, and you're going to get competed out, right? Unless you are, one of the big, absolute big dogs who can push everybody else out. It's kind of now or never for that check. Like you should just wire him an uncap safe and go, right? Let that safe follow the rest of the round. Like don't worry about the valuations. Just give him money and go, and he'll figure the rest out. But if he figures it out without you, like you're out and you lost, all of the alpha on that. So I think this category of pre-seed is like misunderstood. And I think that people are indexing themselves out of the really, really good founders, right? I think there's a bunch of pre-seed firms who are like sort of definitionally excluding themselves from the best founders by trying to treat pre-seed as like a round with a lead, right?
Yeah.
So you can get around that by just like a pre-seed founder sort of by definition needs a couple $100K to keep moving and like get this ball rolling and order this hardware and hire his team, right? Just give him the money. Like you're in the round now. And
if you're the first guy and you do everything right by that person,
yes,
they are going to love you forever.
Oh my gosh, yes. Yeah. And you have an incredible relationship and lots of opportunities in the future. And if you're wrong about him, then it didn't matter anyway. The thing's going to go to zero. If you're right about him and you didn't get into the round, you're going to kick yourself for the rest of your life. So yeah. I think that pre-seed is a very unique category that people need to think about differently. It's really this like, it's more fast moving. It doesn't follow round dynamics. It's like you believe in that person or you don't.
Yeah. I think of this business as something similar to like the ultimate Jeff Bezos business, where he says like, think, 4 or 10 or 20 years and what just hasn't changed, like what doesn't change at all.
Yeah.
And it's like energy. If you can produce lots and lots of cheap energy,
yes,
people will want that product.
Yeah.
How do you think through, planning even a few months, a few like years out, if you're going from no factory to a factory in 30 days,
yeah,
right? How do you plan 6 or 12 months out?
Yeah. So in the long term, Valar Atomics will be making the cheapest energy in the world, right? That's the North Star. We want to make the cheapest energy in the world. We keep it pretty flexible outside of that, right? We know the general form factor is going to be these reactors that are manufacturable. We're going to spin a turbine. We're going to split water, make hydrogen, make hydrocarbons. Like we know the products we're going to make. We know the general form factor of the device. The path to from here to there has to be dynamic and has to be changing, and you have to be finding the efficient edge at all times, right? There's like a theoretical efficient edge of how you get along that critical path the fastest to making money by splitting atoms, by making energy, right? And so, I think this is a mistake that people are making. They're imagining that you can perfectly design a commercial operation with like a full factory design and the perfect product, and you can go get the customers ready for that, and you do all this design on paper for like 5 to 6 years, and then hopefully somebody hands you a couple $1 billion, right?
Just all the planning without any of the execution.
Yes, and you're really hoping that somebody funds your plan with $100 billion, with a couple $1 billion, and I just think that's not true. It's just not how technology works, right? It's how construction works, But the difference with construction is that construction has zero tech risk, right? Like we understand how to build skyscrapers already, and it's really just like do you have like the right capital partners together? Do you have the right engineers like kind of in a stack? And yeah, you can underwrite the risk on that, and somebody gives you $1 billion to go build it. Technology doesn't work that way at all. It has to be iterative. You have to have real hardware milestones behind you in increasing sophistication, and you're just going to learn so much along that journey. Like the reactor in my head today, which is Ward 3, which is our commercial unit, is different from the one that will actually happen in reality. So I hold it loosely, right? Yeah. I have a rough dimension. I have sort of a rough bill of materials in my head. I know how much it weighs in theory. Those
you also know that that's totally going to change.
Exactly, like right. And you need to be ready for that change. And the biggest thing is that your organization has to move fast. You have to iterate rapidly and change your mind quickly when faced with new data, and then build fast, right? You actually have to get through these hardware tests and iterations. So, we have a long-term goal of we're going to make the world's energy. We have short-term problems and constraints that we knock down at the speed of light, and we carry. Actually, you should walk around a little bit. You'll see Mark. Mark carries a baseball bat. He's my chief nuclear officer. He walks around. He carries a baseball bat with him, and it's somewhat symbolic, somewhat not symbolic. But he's ready to bash through whatever barrier comes along, and so that's the frame. You have to navigate through that, very dynamically.
Yeah. So in the past year, like you've accomplished way more than I didn't really know what to think, honestly. Like I was like, this is going to be so interesting.
Yeah.
That's all I knew, is it was going to be interesting.
Yeah.
But it's like very clearly you've hit these milestones that I would not have expected. How has your thinking changed? And like, are you setting more aggressive timelines and like, goals and milestones because of the like progress that you've made thus far?
Yeah, actually, I would say so. I think our aggressiveness has increased over time. I can't talk too much about how that has happened, but there are a couple of areas that we've accelerated that will be even faster than we thought, which is a great place to be. Really, really great place to be. Part of that is that I think the global nuclear environment is changing, right? Like nuclear has become hot. This was not true when we started the company, right? Nuclear was like dead cold. People were like, "What is this weird category?"
Now, is like pre-AI.
Yeah, exactly. So the tech companies just coming in and saying like, "Oh, we are resetting our earnings this quarter because we couldn't power our data centers." Like, all right, that's a red flag. Like, we need power.
They will spend money.
Exactly, we need power. So now that we're post that and these executive orders and everything that's been happening, that helps us speed up. But also we've just grown in confidence in the fact that like we understand the system behind us. We're doing actually the head is off right now, if you can see in the background there, because we're doing a simulated refueling, and we were hoping to do that, project that over like the course of a week and a half or so, and it looks like we're going to get it under a week, and like that's faster than we expected. Fantastic. We got better at doing it from when we packed the first time. So you keep moving, you keep iterating. I sound like a broken record, but I think this really is the most important thing in hard technology is you must move fast, you must iterate fast. You can think about, okay, here's an interesting way to think about it. The exponential growth function. What's the most important term in the exponential growth function? Just intuitively.
I would imagine just like the like multiplier or something.
It's actually the time step.
Yeah.
Right.
Okay.
So if you run a derivative on that, the time step is actually the most important function, right? The most important term in that function. Your interest rate can be higher, but if your time step for compounding is still 2 years, you're going to be slower. Right. But if you have a lower interest rate, but your time step is a month, that is the exponential curve. Right. So in exponential growth, the time step is the most important thing. And the way that we compound is through real world learning, hardware experience, solving problems. And you keep that time step as short as you possibly can. This is why we're suing the NRC. This is why we're not going through the NRC for our first reactor. It's because
talk about that. Like, why are you doing that?
Well, the time step is mandated at like 5 or 6 years, right? That's impossible. That's wrong. And it's not how it worked when we were developing the first nuclear reactors. It's not how it should work now. The lawsuit itself is interesting. Essentially, in 1946, the first Atomic Energy Act gave the federal government, the AEC, essentially blanket jurisdiction over everything that splits atoms. Right? If it splits an atom, it's under the AEC. Again, the logic here was that we were trying to protect a U.S. monopoly, which really started out of the government, right? And so it was like, let's continue protecting that monopoly. Now, from there to 1954, things changed a little bit, right? So Russia got nuclear capability, right? Other allies began to develop their own nuclear capability. And so Congress actually said, you know what, this was important for the first like 5 to 10 years of nuclear, but we've kind of moved beyond that. We need to liberalize the jurisdiction a little bit and allow, we need to allow nuclear to evolve in these like smaller, safer test units, smaller reactors outside of federal oversight. Because, the federal government's really good at these long actions. It's not really good, but
it's all right.
It's all right. It's all right.
It's the best we can do.
It's the best we can. Yeah, there's reasons that you have to have federal regulation for some things, but we know that it's not very good at innovation. It's not very good at facilitating innovation. So let's actually back up a little bit and say the NRC, it was still called the AEC, but it evolved into the NRC, should regulate reactors which are large enough to affect the health and safety of the public and large enough to significantly affect the national security of the United States, right? So national security of the United States means plutonium production and non-proliferation concerns, and so they liberalized it. They went from everything that splits atoms to it has to be big enough and dangerous enough. Unfortunately, after this language was passed by Congress, the AEC did not update their rules. They kept the same rules. So when they actually went to write the CFR, they kept the exact same rules before, which is essentially everything that splits atoms. So the rules written by the NRC are they're incongruent with what Congress has mandated, and it's been that way since 1954. So
it's just like completely smothered the industry.
Yeah, I mean, listen, like the federal government's just not that good at like allowing you to turn on a test reactor. It's a big organization that's thinking about these massive light water reactors, which are making a gigawatt of power, that are mostly a construction-based project, and it's just not good at like you want to go turn on a very small unit like the one behind us. So the lawsuit challenges that and says, this is out of, this is illegal.
Out of your purview.
Yeah, Congress wanted you to create this class of reactors, which is beneath federal concern. And so, this would allow us, our co-plaintiffs are Texas, Utah, Louisiana, Arizona, and Florida. And, these states want to regulate their own small nuclear reactors. They want to say, yes, you can go out, out here in Texas, build a very small reactor. We'll do the regulation on that. We'll make sure it's safe, and you can build a lot of them. So we're super excited about that.
Yeah. So when I interview you next year, let's say July-ish, what is going to have happened by that date?
Well, it depends when in July. So we're extremely excited. Part of these executive orders, the president mandated that there need to be 3 advanced reactors to turn on American soil, split atoms on American soil by July 4th, 2026. July 4th is the 250th birthday of the United States. So this is a very ambitious goal set by the president, and we're charging at that at full speed. So
You're going to try and be one of those first 3.
That's right. So in Utah, I went on Bloomberg with the governor of Utah about a week ago and announced that we have a partnership with the state of Utah to go and hit that goal by July 4th, 2026 at the San Rafael Energy Research Center in Emery County, Utah. So stay tuned for that. Like I said, it's an ambitious goal, but I think Valar Atomics is ready to hit it.
Yeah. What things have you had to kind of like you tweeted a few days ago, about like I love Valar Atomics, but there are definitely aspects to my life that have changed that I miss, like CS:GO,
like Counter-Strike. Yeah,
right, exactly. So what things like personally like that?
Yeah.
Have you just said I'm so focused on this, like I'm going to give that up for now?
Yeah.
Pick it up, when I'm 56 or something.
Yeah.
Yeah. But we're going to focus on this right now.
I mean, everything. Yeah. Everything. It's all consuming. I'm extremely grateful to Sophie, my wife. We have 4 kids at home, 4 amazing kids, and I have to disappear, to DC or to Florida or to the Philippines, all over the place, and try to spend every second that I can, with the family. But outside of spending time with the family, having dinner, there's nothing else. There's nothing else. Yeah.
Yeah. What does a typical week look like for you right now?
Right now in particular, we are really focused on, right now it's this refueling operation, right? We're learning lots of things about how we stack the core, how we unstack the core, how we take the head off, put it back on, think about those gaskets and those seals to make sure that, we're able to do that in a quick timeline. We'll be back into a pressure regime after that, and we'll, continue pushing this to higher pressure, find out what leaks, find out our helium inventory, leak rate, these sorts of things. We're also focused on helping, the government understand how to regulate nuclear reactors, right? This is a really, really important problem that we think we can help out with.
Yeah. Okay. What are you most excited about in the next like 6 or 12 months?
We're going to split an atom, man. We're going to split an atom for the first time. There's nothing else we think about. Yeah. Every day we wake up, we come to work and we think about how do we split an atom in the next year.
Okay. Awesome. We'll end it there.
Awesome.